Matplotlib is a Python module. It's a very popular and standard library for plotting various types of scientific graph. Nice bar graphs, distribution, all sorts of different graphs, different ways of presenting scientific data. And it's very easy to use. I think the one thing that you need to be aware of as you're preparing the data to be graphed with matplotlib is that it usually needs to be organized into lists. There's a lot of ways you can use matplotlib. There's a lot of things you can do. So I want to walk through some of the examples and kind of walk through how you use it. So here's an example of code that will display this graph right here. Nice little bar graph. So we start with this special command, which is specific to Jupyter. Notice it starts with the percentage sign, and it says matplotlib inline. And that's specific to Jupyter to tell Jupyter that when I run the cell, go ahead and display the plot right there and then. After that, you have the import statement. So matplotlib is a library of functions that need to be imported. And in this case, as is common, and we're just going to be looking at one submodule called pyplot. So commonly, we will just import that submodule. You'll do that by the line from matplotlib import pyplot. So there's our import command so that we can use matplotlib and specifically the pyplot submodule, which is all we really need. And then we have pyplot.bar, and that bar function there is going to tell Python to do a bar graph. And then we have two lists, which is our data. And you can see that the first one corresponds to our x-axis and the numbers there. And the second list corresponds to our y-axis and our numbers there. Actually, it corresponds to the values of these bars, and Python automatically gives us these numbers here in this case. The last line there, so we've given the basics there, we've imported it, we've given our data. The last line right there is the pyplot.show. So nothing's going to get plotted until .show is called. So that's always have to end your pyplot calls with .show to make it actually run and get displayed and get plotted. And of course we have there the labels, the X label and the Y label. So there's lots of fancy things you can do. That was just a basic example. Well, a simple example. There's actually a more basic. The basic kind of default plot structure looks like this. So you can get away with just this simple lines of code to come up with a plot. And here we have our import statement, and then we just have one list of numbers. So if you just have one list of numbers, by default, that's going to be the Y values. And the X values will be automatically generated. In this case, we also have a Y label. We do the .show, and this is what comes up. So these numbers are our values here, X and Y. Notice that they're generated automatically. So it's kind of just repeated these. This is 1, 1, 2, 2, 3, 3, etc. on your XY plot. So by default, it's going to get our Y values and then automatically generate the X ones. And we have the label there for our Y axis. Now, if you're going to plot X and Y, there's a few things you should pay attention to. First of all, with those two lists I should say numbers, two lists of data, whatever you have, X is going to come first, Y will come second. So, and then we could see how it's plotted. So this plot ends where Y is equal to 16. We can see that here. And where X is equal to 4. We can see that here on our x-axis. So this is your basic thing. You can get really fancy, however. You can do all sorts of different styles. So you've seen the basic, you plot it with your numbers, your lists. Let's look at some of the fancier stuff here. Just a few of them. There's lots of stuff you can do with matplotlib. So here we have our pyplot with the same numbers we had before. But notice after them we have comma and then a string with RO in it. And this has changed the style of our plot. So the default was a blue solid line, which can also be designated by B dash, but that's the default. So if you don't put anything, it will automatically give you a blue solid line. The RO is giving us these red circles. And here's some other things that you can do to change the way your graph looks. So that's just one example. There's also all sorts of strings that you could put there in your formatting string at the end of the plot call. So B will be blue markers, which is default shape. RO or OR, red circles. Dash G, green solid line. A dash dash is a dashed line with default color. And then the caret K colon is going to give you a black triangle with markers that are connected by a dotted line. And you can kind of look at these are not all of them, but you can look at these and kind of mix and match with the shapes and the colors together and kind of figure out what sort of styles you can do. The other thing that we have here is you can change the size of your graph, and you can use this with the axis function there. And this is also, there's 4 numbers there, but they're matching up also to the XY order. So that first, or we're looking at the second 0 here, actually is where the y-axis begins. And then the last number is going to be where the y-axis will, sorry, that 0 is where it starts at the bottom there, and 20 is where it stops. And then the first 2 numbers, of course, are for the x-axis. So the 6 is where that number, the graph's going to end, it's going to go up to 6, and 0, of course, is where it starts. So there's some changes and default things we can set, change the size, change the colors and shapes. You can put multiple plots on one graph and do some pretty cool stuff. So here's a long list of numbers. So we have our import statement there, and then we have 2 long lists of numbers. We have the list t and t squared. So in this case, we put our information into a variable, and we're going to use the variables down here in our plot function. And we just, we do it xy, but we can keep on adding xy calls. So our first plot is going to be t is going to take the values from the t list as the x, and again for the y values. And it's going to plot that with a red dashed line. So there you have. The second plot in that same graph is going to take the t values as its x and the t squared as its y values, which is going to give us the exponential growth that we see there with the blue squares. So that's what BS here is in that case. It's blue squares. And you can do multiple of these. Now we can change that. So red double dash is a dashed red line, and BS in matplotlib is blue squares. We can change that very simply by changing what's in our formatting string. So green with caret is going to give us green triangles. And you can get into matplotlib and play around and try all sorts of things. It's a lot of fun. Rather than go on and on, the best resource I can give you is this link right here as a gallery of examples. And it's a really good place to go and find how to work with matplotlib. The nice thing about it is you can kind of look through this gallery, you can see a chart that looks like something you want, and then click in and look at it, and it will give you the code for how to create that chart. So you can copy and paste that into your Python program, and maybe just leave it as it is and give it your numbers, your list of numbers rather than theirs, or play around and change the colors and the styles and the size as you wish. So I really encourage you to go in, click on the link, and just play around a little bit, look at some of the code, note some of the commands. We mostly looked at just the plot command, and then we also saw the bar command to give us a couple of different kinds of chart, but there's all sorts of charts that you might want to do and mix and match, I guess, maybe with different styles and colors and figures and objects on your graph. So matplotlib is a module. It's a very popular module in Python, and one that you will want to be familiar with because we will be using it in this course.